12.5. I spend a ton of time typing up things on my website, and when I try to lecture using the material that I typed up, my lectures just aren't that good. Not that this is going to be a great lecture, but it's going to be better than what I would have done with my notes in front of me. For some reason, they just really don't help me lecture. So I'm going to lecture on 12.5 without the handout, but I'll cover everything in the handout. So in order to get into section 12.5, there's some ideas that we need to understand, and that's what I'm going to start off doing. So there's homework problems. That's the exact same homework that's on the syllabus. There's problems that I'm going to do. I don't know why I circled the 8. And one of the homework problems I'm actually going to do when I lecture, just because there wasn't anything like it in the text, and it was important enough that I didn't want to skip over it, and I wasn't sure you'd be able to do it without me showing you how to do it ahead of time. So if I jumped right into the problems, that might be a bit much. So I need to do a little bit of introduction, and the introduction I'm going to do, I need to make you understand a couple of things, and the two things that I need to make you understand are the concept of sample space and something called the counting principle. And I'll lecture kind of outside the text a little bit, although my lecture is going to probably, you'll start to see some of my lecture as we get through the problems, but I'm just going to kind of lecture freely right now to introduce these concepts, and then once I feel like I did a reasonable job of introducing these concepts, then I'll do these problems from the text, and then after I do the problems from the text, you should be able to do the homework problem. When you're watching the video, it's always great if before I do a problem, if you feel like you might know how to solve it, to pause and solve the problem before me, because that was going to do you a world of good. If you have the ability to solve a problem without me solving it for you, then you're way ahead of the game. So a sample space is a word that gets thrown around in this section, and formally we can say it's the sample space is all of the possible outcomes for an experiment. Experiment is kind of a stretch for a word, but it's the word that is often tossed about when you're talking about probabilities. So I'm going to define an experiment, and I'm going to list the sample space, which is all the possible outcomes. So here's my experiment. A coin is flipped 3 times. 3 is going to be an important number here. And a sequence of heads and tails is recorded. I'll say list the sample space for this experiment. If you've never done this before, then this might be a hard question for you to answer, but let me give you an idea of what an element or two in the sample space would look like. If I wrote something like this, H, T, T, this would represent getting a head on the first flip, and a tail on the second flip, and a tail on the third flip. Something like this, T, H, T. This would be something that also be part of the sample space. It's not the same as this event. So this would be a tail on the first flip, a head on the second, and a tail on the third. If I'm clever, I might be able to list the entire sample space in a very random fashion. That's really hard to do. So normally when we're asked to list a sample space, we like some structure in creating our sample space. And more often than not, that structure that allows us to create the sample space, we do that by making a tree, or I guess I'll just call it a tree. So I'm going to construct the sample space for this experiment, and I'm going to make sure I get all the elements by making some sort of tree. And what I'm going to do is I'm going to start off, and I'm going to make beginnings of a tree. And I'm going to start with a point, and on my first flip could be a head or it could be a tail. So I have a tree that kind of has two branches, and this represents getting either a head on my first flip or a tail on my first flip. Then I'm next to under my tree, I'm going to write something for my second flip, because I'm going to flip this coin 3 times. And under each of the letters, I'm going to make a branch with two, kind of make a V essentially. And on the second flip, I could get a head or a tail. Following the tree down this way, this would say I could get a head on the first flip and a head on the second flip, or a head on the first flip, a tail on the second flip. And if I do this thing with this tail, I could see a tail on the first flip, a head on the second flip, and a tail on the first flip, a tail on the second flip. There's 3 flips that I need to do, so I need to do my third flip. And under each of the letters, head and tail, I'm going to do the same thing. I'm going to make a branch that has 2, or V essentially, and at the end of each V, I'm going to write a HT. If I count the number of in my bottom row after my third flip, there's 1, 2, 3, 4, 5, 6, 7, 8 letters in my third row. There's going to be 8 elements in my sample space. So to create my sample space, I need to get from the top to each of the bottom letters. To get to this H down here, starting at the top, that would represent getting a head on the first flip, getting a head on the second flip, and getting a head on the third flip. So one of the 8 elements in my sample space would be getting a head on the first flip, a head on the second flip, a head on the third flip. I'm done with this H. I'm going to cross it out. I'm not going to use it again. And now I'm going to figure out how to get to the next thing in the bottom of my tree, going from the top. And to get to that tail, I'd have to go from the head on the first flip to the head on the second flip to the tail on the third flip. So the second thing in my sample space is going to be a head first flip, a head second flip, and a tail third flip. I'm going to cross out that tail because I'm done with it. And I'm going to go over to the next thing in my bottom row, which is a head. To get to that head, I need to have a head on the first flip, a tail on the second flip, and a head on the third flip. So to get from the top as efficiently as I can to this head, it's going to be a head on the first flip, a tail on the second flip, a head on the third flip. I'm done with that. I'm going to cross it out. I'm going to get now to the tail that I haven't worked with yet. And to get to that, that's a head on the first flip, a tail on the second flip, a tail on the third flip. So I've crossed out 4 of the 8 things in my bottom row. I have 4 of the 8 elements in my sample space. Now I need to get to this head. To get to this head, it's a tail on the first flip, a head on the second flip, and a head on the third flip. Done with that, I'm going to march over to this tail. To get to that tail, it's a tail on the first flip, a head on the second flip, a tail on the third flip. So it's tail, head, tail. Done with that. Now I have 6 things in my sample space. I'm going to get the 7th by getting to that head. To get to that head, I go a tail on the first flip, a tail on the second flip, and a head on the third flip. And I have one more item to get to. That's this tail. You get to that by having a tail on the first flip, a tail on the second flip, and a tail on the third flip. So there's 8 elements in the sample space. So I've done exactly what I attempted to do. A coin was flipped 3 times, a sequence of heads and tails is recorded, lists the sample space for the experiment. The sample space is these 8 elements. The order's not important. As long as you have those 8 triplets, The order that you write them in isn't important. When the problems get more complicated, it's going to be real nice to know how many elements are going to be in your sample space to know whether you've got them all or not. And that's where the second thing I need to talk about comes in. The counting principle is a technique that you can use to figure out the number of elements that are going to be in your sample space. And to apply the counting principle to this particular problem, how could I have known ahead of time there were going to be 8 elements in my sample space? The counting principle allows me to do this. The counting principle allows me to multiply to figure out how many things are in my sample space. So I'm going to write down each step of my experiment with a little line separated by a time sign. So I have a first flip, a second flip, and a third flip. On the little lines that go above the first flip, second flip, and third flip, I write the number of things that could happen. So on my first flip, I could get a head or a tail, so there are 2 things that can happen. Now I go over to the second flip. When I did my second flip, regardless of what I got in the first flip, I could get a head or a tail, so there were 2 things that can happen. And on the third flip, regardless of what happened on the first 2 flips, there were 2 things that could happen. I could get a head or a tail. If I multiply these 3 numbers, 2 times 2 is 4 times 2 is 8, that tells me my sample space will have 8 elements in it. It doesn't tell me what the elements are, but it tells me I'm shooting for 8 of them. So if I get less than 8, then I'm missing something. If I get more than 8, then I've written something twice without realizing it. So the counting principle kind of goes right in hand with the sample space. The counting principle tells me how many elements I'm going to have in my sample space. And the tree diagram allows you to get your sample space. So flipping a coin is a real common sample space to work with. Let me do another common sample space. I'll do one with rolling dice. So a dice is rolled twice, and the number that was rolled, or the numbers that are rolled, is recorded. So things like this will be part of my sample space. I could roll 1 on the first flip and a 3 on the second flip. Or I could roll a 5 on the first flip and a 4 on a second flip. So this is what I'm talking about. If a dice is rolled twice and the numbers that come up are recorded, these are the kinds of elements that are going to be in my sample space. Let me ask 2 questions. First questions would be, how many elements will be in the sample space? And then 2, physically list the sample space. List all of the elements or the members of the sample space. So it's really nice to know how many before I try to list the sample space. That way I know I can be done more efficiently and be confident in my answer. I'm going to do the how many just the same way. I'm going to have a first roll, like I had a first flip, put a time sign, and then put a second roll. I don't need a third roll like I needed a third flip. When I did the coin problem, because I was flipping a coin 3 times and needed a first, second, and third flip, this problem I'm only rolling a dice twice, so I only need 2 bars that I'm going to put numbers in, and the numbers aren't 2 and 2 this time. I'm assuming that my dice is a standard 6-sided dice, and it has the numbers 1, 2, 3, 4, 5, and 6 on it. So when I roll the dice, my first roll can be any number between 1 and 6. And then I pick it up and roll it again. The second roll can be any number between 1 and 6. So there's going to be 6 times 6 are 36 elements in my sample space. So that's way bigger than 8, so it's going to be kind of a nuisance to write. When I go to list all my elements, if I try to crunch them on the bottom of this page, I may run out of room. I'm going to list the elements again doing a tree, but my tree is going to be more complicated because of the 6 options as opposed to 2 options. But I'm going to do something similar. When I made my tree for my head flipping, I made first flip, second flip, third flip. I'm going to do first roll, second roll. I won't have a third roll. But I'm going to get more than 2 branches, unfortunately. So when I go to list my sample space, I start to create spots for each roll. I'm making 2 rolls. So I'm going to have a first roll and then a second roll. On my first roll, I can get a 1, a 2, a 3, a 4, a 5, or a 6. I guess it would probably have been nice if I started with a point and made 6 lines going to it. That's a deal breaker if I did or didn't do that. And regardless of what I get on the first roll, I can get any of the 6 numbers on the second roll. So from my 1, I'm going to make 6 little bars, 6 little lines, and each one's going to have a number going in order from 1 to 6. So this part of the tree shows getting a 1 on the first roll and a 1 on the second roll. I'm putting it in a parentheses just to kind of separate it. And the next thing that this part of the tree shows is getting a 1 on the first roll and a 2 on the second roll. And then I see a 1 on the first roll, a 3 on the second roll, a 1 on the fourth, a 1 and a 4, a 1 and a 5, and a 1 and a 6. So that part of my tree shows all the options that could happen if I get a 1 first. Now I'm going to go to the 2. If I get a 2 first, that doesn't keep me from getting any of the other 6 numbers. So under the 2, I'm going to make 6 branches, and on those branches I'm going to write the numbers 1 through 6. The portion of my sample space that comes from it is getting a 2 on the first roll, a 1 on the second roll, a 2 on the first roll, a 2 on the second roll, a 2 then a 3, a 2 then a 4, a 2 then a 5, and a 2 then a 6. I can already create the rest of the sample space without doing this tree. So at some point, the trees get to be a nuisance. If they give me enough structure, if doing the tree gives me enough structure to finish up the sample space, I don't necessarily need to finish the tree if I don't want to. The next thing I would do with this tree is from the 3, I'd make 6 branches and write the numbers 1 through 6, and that's going to represent getting a 3 first, a 1 second, a 3 and a 2, a 3 and a 3, a 3 and a 4, a 3 and a 5, and a 3 and a 6. I have to remember how many items I'm trying to get. Trying to get 36 elements in my sample space. If I get more than 36, I've messed up and have something in there probably twice. If I get less than 36, I probably missed something. If I did the same thing with the 4 and made 6 branches after it, and put the numbers 1 through 6 on it, I'd get the elements in my sample space that are a 4 and a 1, a 4 and a 2, a 4 and a 3, a 4 and a 4, a 4 and a 5, and a 4 and a 6. And then I do the same with the 5. So a 5 and a 1, a 5 and a 2, a 5 and a 3, a 5 and a 4, a 5 and a 5, and a 5 and a 6. And then with the 6, I'm going to get the same sort of thing, a 6 and a 1, a 6 and a 2, a 6 and a 3, a 6 and a 4, a 6 and a 5, a 6 and a 6. Our author loves dice problems, so having this sample space handy is going to probably be beneficial. So if you've created this, make sure you can have access to it. Notice I didn't do my tree diagrams all the way, and I just didn't have room to make a really pretty tree diagram, but just starting the tree diagram gave me enough guidance to get the sample space. If I count these, there's 1, 2, 3, 4, 5, 6 rows, or 6 columns, and 1, 2, 3, 4, 5, 6 rows. There's 36 elements in the sample space. That's exactly what I was hoping for. There's 36 elements in the sample space, so I think I have them all. So let me create one more experiment, and list the sample space and find the number of elements in the sample space. And then we'll jump into the text itself. So I'm going to make a simple experiment. I'll do this. The letters A, B, and C are written on pieces of paper. Hopefully that's spelled right. And placed in a hat. 2 letters are drawn out one at a time. List the sample space. And then I'm going to put a word that the author uses a lot. If the letters are drawn, I'll say without replacement. And this is the key word here. So I put the letters A, B, and C in a hat. This experiment says I pull one out, I look at it, I write what the letter is, I just toss that letter off to the side, I don't put it back in the hat, and then I pick another letter. If I want to list the sample space, it's nice to know how many elements are going to be in my sample space. So I'm going to make spots. There's going to be the first letter that I pick and the second letter, because I'm just picking out 2 letters to figure out how many elements are in my sample space. I make a spot for each of the things I'm doing. I'm pulling out 2 letters. For the first letter, I'll have 3 choices. I could pick the letter A, B, or C. When it says without replacement, once I pick a letter, I can't pick it again. I'm not putting it back in the hat. So when I go to pick the second letter out, one of the letters is going to be gone. I don't necessarily know which letter I pick, but there's only going to be 2 letters left in the hat. So there's only going to be 2 letters to choose from. So the number of elements in my sample space are going to be 6. So when it says without replacement, I'm assuming I'm not putting my letter back. So there should be 6 elements in my sample space. Let me try to list the sample space. So I'm going to go first letter. I could actually spell first. Then my first letter can be an A, B, or C. Now I'm going to do my second letter. If I draw the A first, I'm not putting it back in. My second letter can't be an A, it can only be a B or a C. So 2 of the elements in my sample space would be drawing an A first and then a B second, or drawing an A first and a C second. I can't have an A then an A, because once I pull the A out, I'm not putting it back, because when I say without replacement, it means I'm not putting the letter back. If I draw a B first, I can't draw a B again, but I could draw an A or a C. So in my sample space, I could have a B first and an A second, or I could get a B first and a C second. And lastly, if C is the first letter that I draw, I can't draw another C, but I could draw an A or a B, and the elements in the sample space from getting a C first are a CA and a CB. If I count these up, there's 6 elements in my sample space. So if our author uses the word without replacement and he wants us to list the sample space or count the number of elements in the sample space, I have to I have to increment down as I make my second choice here. If the author would have not used that word without replacement, and if the author would have asked the same questions, but if he said, list the sample space if the letters are drawn with replacement, when the author uses the word with replacement, what the author is assuming is I pick a letter, I look at it, I write down what I pick, I put that letter back in a hat, and then I pick a letter again, so I could get the same letter twice. If I want to list the sample space, it's nice to know how many things might be in the sample space, and for this particular experiment, there were 3 letters I could get for my first choice. I'm putting the letter back in that I pick, and there's all 3 letters to choose from the second choice. So my sample space is going to have 9 as opposed to 6. So without replacement, you couldn't get a double A, a double B, or a double C. With replacement, I'll have the doubles that are acceptable. To list my sample space with replacement, on my first choice, I could get an A, a B, or a C. They're also going to be in the hat. For my second choice, if I get an A, I still could get an A, B, or C for my second choice. So part of my sample space would have a double A, getting an A first and an A second, and then an A first and a B second, and an A first and a C second. Similarly with the B, if I get a B first and throw that B back in, on my second pick, I still could get an A, B, or C. So my sample space will have a B first and an A second, a B first and a B second, a B first and a C second. And then if I get a C first and put the C back in, I could still get an A, B, or C for my second. And the sample space from that would be a C first, then an A C first, then a B, a C, then a C. If I count these up, there's 9 things if I do with replacement. There's always going to be more elements in the sample space if you replace than if you don't replace. So that's everything I can think of that are the big things that we need that are new to this section. So now I'm going to dig into the book, and as I start my book problems, I'm going to start with number 8 and kind of work my way, do 8, 12, 14, 16, 19, 20, and 24. Part of the issue with this section is just understanding what the author is asking. Sometimes the author is going to ask me to list the sample space. Sometimes he's going to ask me how many elements are in the sample space, and I'm not going to list the sample space. He'll just say how many elements are in there without listing them, because maybe the sample space is so big that it's impractical to list. And then sometimes the author is going to ask me probability questions, and I'm going to answer the probability questions much like I did the probability questions in section 12.2. So let's see what happens here. So 8's the first problem I want to make a stab at. And 8 should be quite a bit like number 7. And so the reason I'm picking 8 is because I assigned 7 and they have the same skill. So this is section 12.5, number 8. It has a part A and part B. And hopefully you have your book handy, because I doubt that you can read 8 from here. But it says selecting dates. It says if 2 dates are selected at random from the 365 days of the year, use the counting principle to determine the number of possible outcomes if the dates are selected with replacement or without replacement. So what the author is asking me in number 8, if I was going to list the sample space and my experiment was picking 2 days, like the first day I pick could be February 1st, the second day I pick might be September 15th. That's picking 2 days at random from the 365 days. My sample space would look like that. I could have, December 3rd, November 2nd, first date, second date. It would be practical, if not impossible, to list all the dates combinations that are possible. So the author doesn't ask me to list out the sample space. The author wants me to use the counting principle to figure out how many things would be in the sample space. And the first part is with replacement. And what I'm going to do is I'm going to figure out the how many by making 2 lines, because I'm picking 2 dates. I'm going to put a time sign between the 2 lines, and above the time sign I'm going to put the number of elements that are possible for that particular choice. So for part A, I'm going to pick a first date, and then I'm going to pick a second date. I am not writing the words, but under there I could have said the first date that I pick, the second date that I pick. I know for the first date, the author tells me there's 365 days of the year. So there's 365 days that I could write from January 1st to December 31st. And then I'm going to write a second date. When the author says with replacement, when I pick a date, I'm allowed to use it again. So if I picked December 31st for the first date, I'm allowed to use it again. There's going to be 365 dates for my second date. If I multiply those 2 numbers together, that's how many elements would be in the sample space if I was going to list out the whole sample space. And it's going to be a big number. So 133,225 would be the number of elements in the sample space. And so the author could never really ask us to list out the sample space because you could never finish it, essentially. But we can still know how many elements are in the sample space without actually listing the sample space. Part B is the same question. I'm picking days, picking 2 days, one after another. And part B, without replacement, says once I pick a day, I'm not allowed to use it again. So when I make my 2 spots, the first day that I pick, there's 365 days to choose from. I write my time sign in between. The without replacement says once I use a date, I'm not allowed to use it again. So for my second choice, there's only going to be 364 days, as opposed to the 365 days if I'm putting a date back and letting me use a day twice. If I multiply those 2 results, I'm going to get a smaller number. There's only going to be 132,860 combinations of putting 2 days in a row, like June 1st, June 2nd, or July 1st, March 3rd. There's less of them when you do without replacement because there's less choices for your second. So that's just an example of using the counting principle. I found out how many items would be in the sample space without actually listing the sample space. And I generally can use the counting principle to answer how many questions even without listing the sample space. That's the skill the author wanted us to deal with there. Now I'm going to jump over to number 12. And this is a pretty classic problem. So number 12, if I read through it, it talks about boys and girls. It says a couple plans to have 2 children. And first thing it says, determine the number of points in the sample space of the possible arrangements of boys and girls. This sample space is going to look something like my coin sample space. With my coins, I put like head, 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 tail, tail, head kind of things. The sample space for boys and girls, for couples having kids, like BB would be having a boy first and a boy second. BG would be having a boy first and a girl second. So in number 8, the kinds of things that are in my sample space are going to be like the head, 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 tail, but they're going to be BGs and BBs, or GGs and GBs. BG would be having a boy first and a girl second. So part A wants to know the number of elements in my sample space. So I'm going to make 2 lines because the couples are having 2 kids. And in my sample space, when I get around to listing it, I'm going to have a first child, and then I'm going to list a second child, or an oldest then a youngest. And for the first child, there's 2 choices. It could be a boy or a girl. And I assume that regardless if you have a boy or a girl for your first kid, you can get a boy or a girl for your second kid. So there's going to be 4 elements in my sample space. Part B says make a tree diagram and list the sample space. So I'm going to make a tree diagram. I'm going to make a spot for a first child. My first child could be a boy or a girl. And then I'm going to make a spot for my second child. Regardless of what my first child is, my second child could be a boy or a girl. And now I'm going to list the sample space. So I only had to make 2 lines as opposed to 3. When I did my coins, I did 3 levels because I flipped the coin 3 times. To get to this B, that would be having a boy first and a boy second. To get to this G, that would be having a boy first and a girl second. To get to this B, it would be having a girl first and a boy second. And to get to that G, it's having a girl first and a girl second. If you look at my prediction, there were going to be 4 elements in my sample space. I have 4 elements. That's perfect. I've answered question B and A perfectly. I predict that there's going to be 4 elements in my sample space. I've listed the 4 elements. Now I can answer some probability questions. And I want to find the probability that... And now this is going to be a skill that shouldn't be new. It's a skill that comes out of section 12.2. Find the probability that the couple has, it says 2 girls. The denominator for all my probabilities is going to be 4 because there's 4 different outcomes that can happen. The numerator is going to be the number of items in the sample space that have the desired look. And for this particular problem, the only thing in the sample space that has the look of 2 girls is that double G. So the probability of having 2 girls is 1 in 4. When I go to do part D part D says, what's the probability they have at least one girl? I know the denominator is going to be 4 because there's 4 elements in my sample space. I'm going to go through and circle all the items in my sample space that have at least one girl. This BG has at least one girl. This GB has at least one girl. And this double G has at least one girl. 2 is at least 1. So the probability for D is going to be 3 and 4. In part E, says what's the probability they have a girl first, then a boy? The denominator is going to be 4 again, and I look through my sample space for something that has a girl first and then a boy, and that's only this one right there. There are other ones that have a girl and a boy, but not a girl first, then a boy, so the probability of that's going to be 1 in 4. So once I answer the question, how many elements are in my sample space, I can be pretty accurate, pretty sure my sample space is right. Then I could use my sample space to answer probability questions. And that's kind of the gist of most of the problems that we're going to do in this section. So that's problem 8. The next thing I'm supposed to accomplish is problem 12. And problem 12 is paralleled with problem 13. If you read problem 12, it says look to problem 13 and change the wording and answer the questions again. So when I go to do problem, whoops, I take that back. I just did problem 12. The boys and girls was problem 12. So problem 8 was the date problem. I did that. Problem 12 was what I just did with the boys and girls. I'm going to do problem 14. Problem 14 and problem 13 are the problems that are paired up. They're going to solve essentially the same way. They're just going to be slightly different. So I'm going to look at read 13 real quickly and then answer 14. 14 says repeat exercise 13, but change the words to without replacement. So if I read through problem 13, because that's ultimately what I'm doing, just changing the word to without replacement, it says a box contains 3 cards. So I have a circle card, a square card, and a triangle card. I'm gonna call this circle, square, triangle. Rather than trying to duplicate the cards, I'll write C for the circle card, S for the square card, T for the triangle card. And I'm going to take 2 cards, I'm going to select them at random, and I'm going to take them without replacement. So the difference between 13 and 14 is 13, you're taking a card, you're putting it back in, just like I took a letter and put it back in. With 14, I'm taking a letter, and once I take it out, I'm leaving it out. So the first thing I want to do in problem 14 is determine the number of points in the sample space. So I'll do that. So for 14A, the number of points in the sample space I'm picking 2 cards, so I'm picking my first card, then I'm picking my second card. Whether I have with or without replacement, there's 3 cards to pick for the first card. If this was problem 13, it's with replacement, I'd have a 3 again. Problem 14, the author says I'm picking cards without replacement, which means once I've picked a card, I'm not putting it back. So for my second card, once I've picked one of the 3 cards, there's only 2 cards left. I'm not putting back the first card. There's going to be 6 elements in my sample space. Now I'm going to list my sample space for part B. I'm going to construct the sample space. And I'm not drawing pictures, but I can do well enough. So for my sample space, for the first card, I can get a circle card, a square card, or a triangle card. For my second, if I pick the circle, I can't get the circle again. I can only get the square or the triangle. If I pick the square, I could only get the circle or the triangle. If I pick the triangle, I could only get the circle or the square. Notice I got lazy. I didn't say first card, second card. Those are just kind of implied. So the sample space is going to be getting a circle card, then a square card, a circle card, then a triangle card, a square card, then a circle card, a square card, then a triangle card, a triangle card, then a circle card, a triangle card, then a square card. So for part Question 14, because I'm not having with replacement, I didn't have the double C, the double S, or the double T. I couldn't get a card twice. Now I'm going to do some probability questions. And the probability questions I need to answer, what's the probability for part C, the probability that 2 circles are selected? The denominator is going to be 6 because there's 6 elements in my sample space. The numerator is going to be the number of elements in my sample space that have 2 circles. In this case, there's none because I'm not doing with replacement, so it's impossible for me to get 2 circles unless I put the circle back in. Part B, what's not part B, it's part D. Part D wants to know to get a square, then a triangle. So it very specifically tells me the order. It says a square, then a triangle. The denominator is 6. The numerator is 1 because there's only one element in the sample space that has a square first and a triangle second. And lastly, part E, it says at least 1 circle is selected. And in terms of my sample space, that would be 1 or more circles. That's all of these. There's at least 1 circle, there's at least 1 circle, there's at least 1 circle, and there's at least 1 circle. There's 4 elements in my sample space that have 1 circle. That's at least 1 circle. So I'm going to say it's 4 and 6. I'm going to reduce that to 2 and 3. So once you get the sample space created, the probability questions are just looking at your sample space. The numerator is going to be keyed in the words. The numerator is going to ask you to search through the sample space for all the things that have that characteristics, and the number with that characteristic goes in the numerator. The denominator is the number of things in the sample space. In this case, it's 6. So that's 14. The next thing I'm supposed to do is go down to 16. And 16, I don't know if I created that sample space already. I think I did. 16 is 3 coins are tossed, and it should say in a sequence of heads and tails is listed. Determine the number of points in the sample space, construct the sample space, find the probabilities. So for 16, I'm flipping a coin 3 times, or 3 coins 1 at a time. Somehow I like order in these. So 3 coins are tossed. The first coin could come up a head or a tail. So when I do 16A, how many things there will be in my sample space? The first coins can be a head or a tail. The second coin could be a head or a tail. The third coin can be a head or a tail. There's going to be 8 elements in my sample space. And when I do this, I do first coin. When I list my sample space, I do a tree. First coin can be a head or a tail. The second can be a head or a tail. The third can be a head or a tail. So I need 3 levels to my tree. 1 for the first coin, 1 for the second, 1 for the third. That's the same as first flip, second flip, third flip. They work the same way. Somehow I'm assuming I could distinguish the coins. Maybe they're different colors, and I could say that's the first coin, this is the second coin, that's the third coin. Or a red coin, a green coin, and a blue coin. Somehow I need to be able to tell them apart. So my sample space to get to this one, it was an HHH. Try to get 8 elements in my sample space. To get to this T, it's HHT. To get to this H, it's HTH. To get to this T, it's HTT. To get to this H, it's THH. To get to this T, it's THT. To get to this H, it's TTH. And to get to that T, it's TTT. So I went through it kind of fast with the idea you can pause it and work your way through that. There's 8 elements in my sample space. All the probability questions that the author asks me, I'm probably going to throw an 8 in the denominator. So now I want to find the probability. The first probability is that no heads are tossed. The denominator is 8. The numerator is anything that has no heads, and that's the only one there, is that TTT is the only one with no heads. So it's 1 in 8 chance that you get no heads. For part D, it says exactly 1 head. It's real easy to miss or count something you shouldn't count. The denominator is going to be 8. The numerator has exactly one head. That means one head and two tails. That one right there has exactly one head. This one has exactly one head, and that one has exactly one head. Those three that I just circled, they have one head and two tails. Any other ones that aren't just recently circled have more than one head or no heads. So this probability to get exactly one head is 3 in 8. And the last part, E, the probability that 3 heads are tossed. The denominator is going to be 8 because there's 8 elements in my sample space. The numerator is going to be 1 because there's only one thing in my sample space that has 3 heads. So that takes us through 8, 12, 14, and 16. The next problem I'm supposed to do is 19 because it's the dice rolling problem, and the dice rolling problem, that was the only dice rolling problem, but the author does a lot of dice rolling problems throughout the chapter, so I felt like I just needed to do this for you. And when I started this section, I answered some of the dice questions. I answered, if 2 dice are rolled, or dice is rolled twice, how many elements are in the sample space? There are 6 things for the first roll, second thing for the second roll. So I'm going to roll 2 dice, kind of one after another, so I can tell the rolls apart. So for part A of numbers, so when I do problem 19 says 2 dice are rolled. That's the same thing as rolling 1 dice twice. Determine the number of points in the sample space. The answer to 19A is going to be 36 because there's 6 things the first dice could come up, or 6 things I can get on the first roll, and 6 items I can get on the second roll. So there's 36 elements in my sample space. I've already constructed that sample space, so I'm going to use the sample space that I've previously constructed to answer. So this is the sample space. This is the answer to 19B. This is the sample space that the author is going to want us to use for every time that we're rolling a dice twice or rolling 2 dice. Somehow, if you're rolling 2 dice, you kind of need a green and a red one, so you can tell the dice apart. So you can say, this is the green, this is the red dice. You need to be able to discern which dice comes up which number. So the sample space is done. Now I can answer the probability questions. There's 36 numbers here, so when I do the probabilities, when I try to do 19C and find the probability, my denominator should be a 36. So what's the probability that a sum of 7 is rolled? I haven't summed any of these. The denominator for all my probabilities is going to be 36. And this is tricky because they're not summed. This element down here getting a 6 first and a 1 second, that's considered getting a sum of a 7. If I add the numbers on the 2 dice, that comes up to a 7. Similarly, this 5 and this 2, this 4 and this 3, getting a 3 first and a 4 second, a 2 and a 5, and a 1 and a 6. Those are all the elements in the sample space that have a sum of a 7. So if I add the 2 numbers, like that 2 and 3 gives me a 5. There's 6 elements in the sample space of the 36. So the probability of getting a sum of a 7 is 1 in 6. Part E is, so that was actually oh, I skipped, that was actually D. Messed up there. Part C, I'll go back to that. Part C is rolling a double. And the author called a double like a 1-1 or a 2-2. So for part C, the denominator is going to be the 36. The numerator is going to be all the doubles. That's the 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. This is also going to be 6 and 36. There's 6 elements of the sample space that are doubles, and 6 divided by 36 is 1 in 6. So I did D and called it C. D was rolling a sum of 7. That's those 6 of the 36. And when I deal with E, E asks me what's the probability of rolling a sum of a 2. The denominator is going to be 36. The numerator is going to be anything that sums to 2. And the only way to get a sum of the 2 dice to be 2 is to get a 1 and a 1, because those 2 add up to 2. So that probability is 1 in 36. Part F says, are you as likely to roll a sum of a 2 as you are a 7? No, you're more likely, for part F, you're more likely to roll a 7, a sum of 7, than a 2. because there's a 1 in 6 chance of rolling a 7, but only a 1 in 36 chance of rolling a 2, because there's more ways to get a 7, so it's more likely. Always when you're working problems, it can never hurt to check. So I just did an odd problem, and so this is section 12.5, and I just did number 19. So it's always when you're doing your homework, it's a very safe thing to do is look at the author's answer and see how it matches up to yours. So the author for part A, if you can hopefully read this is on page A51, way in the back of the book, gave me the 36 that we came up with. There was 36 elements in the sample space. You notice the author writes his trees sideways. There's getting a 1, then a 1, 2, 3, 4, 5, 6, a 2, then a 1 through 6, and so forth. The reason the author does them this way as opposed to this way is it fits easier on a page. Putting it this way, it would take up too much room. Your trees can go, I make my trees going down always. Our author makes them going sideways. It doesn't matter. But you can see the same sample space. So 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and so forth. When I look at the answers, the probability of rolling a double reduced to a 1 in 6. The probability of rolling a 7 was 1 in 6. The probability of rolling a sum of 2 was 1 in 36. And no, it's way more likely to get a 7 than it is a 2, because there's only one way to get a 2 and 6 ways to get a sum of a 7. Sometimes I can't sense if things are really easy or not. And probability is one of those things that there's kind of no middle ground. Like we had that horrible test on the money where there were all A's and F's and nothing in the middle. Sometimes probability works that way too, but it won't be as drastic. There won't be equal amounts of A's and F's, but this is the kind of test where there's not going to be many middles. So if you're not feeling good about the material and you're worried you're going to get into one of those bottom grades, then you really need to ask me a lot of questions and let me make you understand these, because this is not impossible to understand, and you don't want to get a bad grade on the last in-class test. On the take-home test, you'll have ample time to study, and hopefully everybody does well on that. Okay, so that was, I've already lost my sheet of what I'm supposed to be doing, which is probably not so good, but we'll get back to that in a second. So that was problem 19, and just have a few more problems that I said I was going to do. Not that I could find oh, there it is. I need to do problems 20 and 24 next. 20, I didn't really like the way it was worded, but I kind of felt obliged to do it. I read through it, and it actually took me a second to figure out exactly what the author wanted. And so I thought I'd do it, because it's not intuitive. So 20 talks about a homeowners association, and a board member can vote yes, he can abstain, or no on a motion. And there are 3 motions the board is voting on. So for one member, what votes could he do? Like on the first one he can vote yes, on the second one he could abstain, on the third one he could vote yes. So the kinds of things in my sample space for number 20, just to get an idea. So there's a motion 1, a motion 2, and a motion 3. So the guy might go yes, no, yes on 1, 2, and 3, or he might abstain, no, and no. So those are the kinds of things that could be in my sample space. If I want to know how many elements are in my sample space, for the first motion, the person could answer yes, no, or abstain. So there's 3 choices. For the second motion, I'm allowed to do the same vote. I could go yes, yes, yes. So there's 3 choices. And for the third motion, there's going to be 3 choices. There's going to be 27 elements in the sample space. Now I need to construct the sample space, which really sucks, but I'll do this. So now I'm going to make the sample space, and it's going to have 27 elements. I'm going to do this. I'm going to have a first vote. So this is going to be the first motion, or my first thing that I'm voting on. I could answer yes, no, or abstain. And then I'm going to do the second. For the second, I can do yes, no, or abstain, regardless of what I did on the first. And for the third, regardless of what I did on the first 2, I can do yes, no, and abstain. And let me start doing this the sample space before I fill out this whole thing. So I'm going to have a yes, yes, yes. So a yes on a first, a yes on a second, and a yes on a third. And then I see a yes, yes, no. That would be a yes on the first, a yes on the second, a no on the third, and then a yes, yes, abstain. So this branch is taken care of, and now I'm going to go from this one and do a yes, no, abstain. And this is going to be voting yes on the first, no on the second, yes on the third. That takes care of that. The next one is yes on the first, no on the second, no on the third. That takes care of that. And then yes on the first, no on the second, abstain on the third. That takes care of that. Now I'm going to do this A. Yes, no, abstain. Getting this is going to be yes on the first, abstain on the second, yes on the third, then yes on the first, abstain on the second, no on the third, and then yes on the first, abstain on the second, abstain on the third, and it's done that. Oh my gosh. So that's only 9 of the 27. Let me go from this no. So I'm going to go no, yes, and then yes, no, abstain. So for this branch right here, I see a no on the first, a yes on the second, a yes on the third. That takes me to that. And then a no, yes, no. Takes me to that. And then a no, yes, abstain. That takes me to that. Now I'm going to do this no. I'm going to do yes, no, abstain. It's going to be no, no, yes. And then no, no, no. And then no, no, abstain. And I'm done with that. I'm going to go to this one and do yes, no, abstain. It's going to be no, abstain, yes. And then no, abstain, no. And then no, abstain, abstain. And then all of a sudden you need to be able to read your sample space, and that's not necessarily going to be the case here. So I have 9 here and 9 there. I have 18. I'm going to go for this, A, Y, and then yes, no, abstain. So this is going to be A, Y, Y, A, Y, N, A, Y, A. And then for this, yes, no, abstain. It's going to be A, N, Y, A, N, N, A, N, A. And then lastly, yes, no, abstain. A, A, Y, A, A, N, and A, A, A. And I have 9, 18, 27 elements in my sample space. That's really a bit absurd to ask you to list 27 elements for a sample space. And now to ask probability questions, it's going to be equally tough because my sample space isn't written very neatly. Let me write it again so I can answer my questions better. So I'm just copying my sample space, trying to write it slightly neatly so that I have a shot at answering the probability questions. These are still going to be tricky because it's going to be really easy to miss one of the elements that I'm looking for. So I know that when I answer the probability questions, my denominator is going to be 27, but my numerator is going to be sifting through this sample space to find all of the elements in the sample space that have the characteristics that I'm looking for, and it's going to be really easy to miss one. So if I make a mistake, it's not going to be the end of the world. It's definitely highly possible that as I'm going through this, I make a mistake. So that's the sample space the author wants for number 20. Now I want the probability that the author goes no, yes, no in that order. So for part C, the probability that the guy goes no on the first, yes on the second, no on the third in that order. The denominator is 27. That's an easy one. There's only one thing in the sample space that has a no first, a y second, and a no third. So the probability of answering no on the first, y on the second, and no on the third is 1 in 27. That was a friendly one. Part D, it says yes on exactly 2. So yes on exactly 2. That's going to be worse. So this is exactly 2 yeses. No, 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 no. Don't see any there. There's an exactly 2 yes. Not there, not there. Not counting that anymore. Not there, not there. There's 2 yeses. There's exactly 2 yeses. Exactly 2 yeses. Exactly 2 yeses. I think I went through and successfully circled all the ones in my sample space that had exactly 2 y's. And that's 1, 2, 3, 4, 5, 6 out of the 27. And that's reducible by 3 to 2 over 9. And hopefully I didn't miss one, but I don't think I did. And then part E, yes on at least 1. Ugh. The denominator is 27. The numerator is anyone that has a yes anywhere. So there's 1, 2, 3, 4, not counting that one, not counting that one, 5, not counting that one, not counting that one, 6, 7. As long as I have a y, I'm counting them. Doesn't matter how many, at least just one. So I have 3, 5, 7, 8, 9, not counting that, it doesn't have a y, not counting that, it doesn't have a y, 10, no, no, 11, 12, 13, 14, 15, 16, 17, 18. Looks like there's 19 of the 27 in the sample space that have at least one y, which means 1, 2, or 3 y's. So hopefully I didn't mess that up, and hopefully it was tolerable to follow. I wouldn't ever ask on a test for you to create something that has 27 elements in the sample space. That's, a bit obscene. 8's a lot. 16 would probably be the biggest sample space on a test that you'd ever be expected to construct. 24. Oh, this is another bad one. But not as bad. 24, if you open up to page 694, tell it's an old book, but we can still do the problem. It talks about somebody going to Computer City, which may or may not have ever been a store. It's not one that I'm familiar with. But anyways, it talks about visiting Computer City. You're going to get a computer, a printer, and a monitor. And you have 4 different computers you're considering between a Compaq, an IBM, which Compaq I guess it doesn't exist anymore, IBM, Apple, and Dell for your computer. And then the printer, you can get an HP or an Epson. For the monitor, I don't know Omega, I know Toshiba, but anyways, you're going to get one of each. To determine how many things are in the sample space, there are 4 computers that I have to choose from. There are 2 printers that I have to choose from. And there are 2 monitors that I have to choose from. There's going to be 4 times 2 times 2. There's going to be 16 elements in my sample space. Now I'm going to construct my tree diagram. My first thing I'm going to do is I'm going to pick a computer. I can pick a Compaq, an IBM, an Apple, or a Dell. And then under each, I'm going to make 2 lines for the printer. And then under the printer, I'm going to do 2 lines for the monitor. So let me show you how I do this sample space for number 24. So for 24, I'm picking a computer, and I can get a Compaq, an IBM, I don't know if they make computers anymore either, an Apple, or a Dell. And then regardless of the computer that I get, I can pick one of the 2 printers. So the next line I'm going to pick is for my printer. And the printer I can get, I'm going to write HP for Hewlett Packard, and then an Epson. HP, Epson. This is getting unpleasant already. This is the kind of thing that I might just believe that I can do and not actually finish the homework problem, but that would just be me. And then under each printer, I put the monitor. And I see Omega and Toshiba. let me start my sample space. My first thing in my sample space is going to be getting a compact computer, an HP printer, and then an Omega monitor, or a compact computer, an HP printer, and a Toshiba monitor. So that takes care of that. Now let me go this. Under this, I'm going to write Omega and Toshiba, and that's going to represent getting a compact computer, an Epson printer, and a Toshiba or Omega monitor, or a compact computer, an Epson printer, and a Toshiba monitor. Now I'm going to go over to the IBM and do the same thing. So under the IBM, I can get an IBM computer, an HP printer, and then an Omega or a Toshiba monitor. So I'm going to go IBM printer, HP monitor, Omega, or IBM computer, HP printer, Omega monitor, or IBM computer, HP printer, and Toshiba monitor. That takes care of that. Now I'll do these. This is going to be getting an IBM computer, an Epson printer, and an Omega monitor, and then I'll do an IBM computer, an Epson printer, and a Toshiba monitor. Now I'm going to do the Apple. So I can get an Apple computer, an HP monitor, an Omega, or an HP printer, an Omega monitor, an Apple computer, an HP printer, or a Toshiba monitor. Now I'm going to do this branch. An Apple printer, an Apple computer, an Epson printer, and a Omega monitor, or an Apple printer, an Apple computer, an Epson printer, and a Toshiba monitor. That takes care of that. Now I go to Dell. I can get a Dell computer, an HP printer, an Omega monitor, or a Dell computer, an HP printer, a Toshiba monitor, takes care of that, and then a Dell computer, an Epson printer, or an Omega monitor, or a Dell computer, an Epson printer, and a Toshiba monitor. Hardly readable, still a nuisance. 16 gets to be a nuisance if the words are big. So if you would have abbreviated with letters rather than writing out the whole words, that'd be better. So that's 24 part B. That's the sample space. Now I'm going to answer the probability. C says, what's the probability that I buy an Apple computer? I know the denominator is going to be 16 because there's 16 elements in the sample space. And the numerator are going to be all the combinations that have Apple for the computer. So those 4 are the 4 of the 16 that have purchasing an Apple computer. So I'm going to say that probability is 1 in 4. For part D, it says, what's the probability that I buy an HP printer? And that's going to be those 2, those 2, those 2, and those 2. So in my sample space, there's 8 that have an HP printer of the 16. So I'm going to say it's 8 and 16, or 1 and 2, a 50% chance that I get an HP printer. And lastly, an Apple computer and an HP printer. I don't have room to write that, so I'm going to try to squeeze it in here. E says an Apple computer and an HP printer. The denominator is going to be 16, and these are the ones that have an Apple computer and an HP printer, and there's just 2 of them of the 16. So I'm going to say it's 2 and 16 are 1 and 8. Hopefully this is more tedious than it is hard. I'm not sure how you're going to feel about it, but watch the video. After you watch the video, try to work through the odd problems. I hopefully have matched up the problems in such a way that you have a resource. So like when you're doing problem 21, if you get stuck on problem 21, it probably has the same skill as problem 20. Similarly, if you're doing problem 25, it probably has the same skill as problem 24. 17 probably has the same skill as 16. So there should be something in the video that you can latch onto. Watch if you're stuck on a problem, one of the homework problems, watch the video of the problem that kind of is right next to it, and that might get you unstuck. And if that doesn't get you unstuck, then come visit me and I'll try to unstick you. All right, that's hopefully enough.